Hi there, everybody. I guess I might be a little bit late to the party on this one, but I figured I'd share what I'd learned anyway. In and around, you've probably found a couple of tutorials on YouTube and the like already explaining how to set up your basic Arma Reforger single player or co-op mission, whatever the case may be. And a lot of them have gone through the basics of how to set up AI and create waypoints and that whole spiel. So I'm not gonna hash over any of that. What I am gonna cover is how to script that behavior in such a way that you can access it from inside of a trigger or a video game or something, or a trigger or an initialization script or something like that that will allow you to automate your AI spawning, so you don't need to necessarily hand place things much the way that people seem to be doing it at the moment. This will involve a level of scripting and an understanding, at least a basic understanding of object-oriented programming. So I'll pull across what I have and just take you guys through it line by line, step by step, just explaining what I've done and how I've done it, and also where I gathered the information from in order to be able to effectively achieve that. Now, I realize that I may go quickly for some people, especially people that are not necessarily coders by trade. Guys that are just into scripting and basic like Arma 3 stuff, the mission makers that came across from there. So I will try explain everything as clearly as I can, but obviously you can leave comments or whatever as you like to, ask questions and let me know if there's anything I kind of hashed over that you didn't understand. Right now, what we have here is a test world that I created, effectively a scenario for that world, so that I could test the functionality of the scripted AI. So it's got your basic stuff. There's a fella on YouTube, and you'll probably see him on Twitter and Twitch and that whole spiel. His name's Useless Fodder. He did a really great tutorial on how to set up your basic missions. Again, I'm not going to cover any of that. I'm just going to focus more on the scripted aspect of that. So to start with that, I've got this script file that I've created. It's called scr_rs_hunterkiller. So hunterkiller is the name of the scripted AI spawner, and that thing is what I've set up. Setting up a script file in Workbench is pretty basic. You go to your file structure. I just shaped my folder structure much the same as the scripts are set up in the base Arma Reforger stuff. So I have my hunterkiller base folder, and then under scripts, game, AI, I have my script scr_rs_hunterkiller. Obviously, creating a new script is pretty simple. You just right click and go click script, or you press the create button on the bottom and go click script. So for those unfamiliar with object-oriented programming, basically you just effectively base your programmatic structure around an object, and that object effectively represents to put it in Arma 3 terms, it represents a script file or a function for those who are familiar with writing functions in Arma. So the main difference, of course, is that an object can have properties, and a script file doesn't really have properties, which makes an object way more powerful because you can use it to store information on an object-by-object basis. This over here, this piece of code, this void, this is what's called a constructor, and that constructor effectively initializes the class. So this thing is the class, and the constructor is like the initialization point for that class. I haven't tried it out in Arma yet, but in most programming languages, you can have more than one constructor. If you're creating the object from different viewpoints with different levels of information, or you're trying to support backwards compatibility for existing functionality and stuff like that, you would create multiple constructors so that you can introduce new variables and so on and so forth. And inside of this constructor, what's happening is actually really quite basic. It takes two optional variables, so these do not need to be supplied. One is an enum that I've created up here, and that just contains the factions that we're dealing with, so US, USSR, and FIA, and then a bool for the extended debug. So one of the Bohemian developers on Twitter, and if I can find the tweet, I might throw it up on the screen here now, but he mentions very explicitly that prints are very resource intensive. So what I've added is an extended debug function or extended debug variable that is defaulted to false but can be turned on, that allows me to print extra information for the running process of the script. It's just for debugging purposes, and it's if you stick it behind an if statement so that if your extended debugging is not enabled, doesn't print the stuff, you will save yourself precious resources. So you can see these variables are listed here under the comment optional variables. I'm setting defaults here as well. That's just in case I want to implement a default constructor, so one that doesn't take anything. But in this constructor here, the unit type that gets passed in and the extended debug value that gets passed in gets set when the constructor runs. So that's just when you new it up. If you supply these optional things, they'll get overridden. Otherwise, it'll just leave whatever these defaults are set to over here. So if we go over to our world and we go to our start game trigger, inside the start game trigger, you can see that some scripts have been set up. And if I open that up, you'll see I have a private bool, and that's just to make sure that this only gets triggered once, and this private reference to the class. So the reference to the class is just to ensure that we can hold the scope once the functionality starts running. This hunter killer initialization in this unactivate thing is straightforward. It's just hunter killer is equal to new scr_rs hunter killer. So this is my constructor. And as I mentioned before, those parameters are optional. So we've given it nothing; it'll just use what the defaults are. And then we execute this this void, which is the only public function. Or the only publicly accessible method inside of my script, or my class more specifically, and that then kicks off the spawning process. If you were to take this SC or the script or the class or whatever and try and initialize it in here, so scrs hunter killer is equal to new scrs hunter killer.spawn hunter killer groups. Inside of this function or this method, it ends the methods in several places. I'll go over exactly what this functionality does, but it ends it by running call later, and that call later just puts the functionality call onto the calling queue, so that you're not running everything in a tightly scheduled straight loop. I'll explain why you need to do that in a second, but to put it in Arma 3 terms, it's the difference between calling a function and spawning a function. What happens is when that call gets added to the call queue, it ends the function. Specifically on return, the void ends, right? And if the hunter killer variable only exists in the scope, this unactivate method will end, and the scope will disappear, and whatever was put onto the call stack will never be executed. The scope of the class is gone, the scope of the call stack is gone, everything just disappears. Okay, so onto the method that handles the initialization. So then what it does is it checks its member variables, are the locations loaded, and then its other member variable, are the locations loading. So the reason I had to do this is the location loader is quite intensive. It finds entities on the map, and I'll explain how it does that in a second when we get to the actual function. And it loads each of those entities such that we can use them to derive positions for the AI spawning later on. And now, when all of that runs in a row, I have, I think, around 63 entities that get loaded, and when they all try to run at the same time, or when it tries to load the entities one after the other, it locks up the game. So effectively, you cause the game to freeze. This was very difficult to do in Arma 3 because of the scheduler. So this mechanism for call later ensures that it's not invoked directly now. It'll hand the function off. So what I did is I created load locations as a recursive function that would load the locations one by one with I think it's a 50 millisecond delay in between each load, just to make sure that we don't lock up the scheduler while it's running. And then, of course, the reason why we have a location loaded and a locations loading is to ensure that while that recursive function is running, that we don't accidentally kick off the rest of the functionality, because we need the locations to be in place before we try and spawn any groups. So the first thing that it does when locations are loading is it calls our load locations method, and that is a protected method that exists down here. And what this thing does is it takes an index, it checks that the index is less than or equal to our spawn locations count minus 1. So spawn locations.count gives you back the number of spawn locations in the array, but obviously with array indexing, the array index starts at 0, so you need to minus 1 from that top value to ensure that you're accessing indexes at the right point. Then what it does is it loads the location name from that array. So I'll go back to the top and explain that array. So I found the location entities, which is effectively just comments for the locations of towns, hamlets, and default locations. So I tried to find a way to load this stuff while it was running. The location specifically, like in Arma 3, you can just call get nearest locations, I believe it is, with a couple of parameters. It gives you back all of the locations present on the map. But at this time, I cannot find a way to automatically do that for Reforger, so I just grabbed the locations that exist in Eden, and Eden or Everon or whatever you want to call it, and I pulled it into this static array over here. So then what this thing does is it loads the location based on the index, then it gets the actual entity for that location, and it inserts it into a private member variable, which is just a reference array of entities, which is our locations. So basically, it takes this string, that is the name of the location, it loads the entity for that location, it puts it in that array, and once it's done that, it checks, okay, have we loaded everything? Or is the index at the max level? If it is, then we say, okay, cool, location's loaded, we're done. Otherwise, we call this method again to load the next location, and so on and so forth. So this method in theory gets called 63 times and then it ends. That's just to load all the locations. While this is happening, while the locations are not loaded and the loading is busy, this spawn hunter killer group ends up in a recursive loop that just comes in to check itself. So every 5 seconds it checks, is the location loading done? If it's not done, then it'll just call itself again and exit. But once it is done, this condition will never be met because our location loaded will be marked as true. It'll fall over to the next thing. So then what it does is it invokes this method called get number of groups to spawn. And this get number of groups to spawn method gets the number of players present in the game. So this is just a sort of, it's a form of difficulty scaling that I baked in. Basically, it gets the number of players present in the match, and then it scales the number of groups to the number of players. So if you have 8 players, then you get 8 groups back. If you have 15 players, you get 15 groups back. But obviously, there's a couple of caveats there. Like if we have all 32 players, we don't want to return 32 groups because that'll give us around 128 AI, which is a little bit excessive. So it checks, okay, well, how many players are there? If that number of players is bigger than 16, then we're only going to return 16. That'll give us 64 AI. If the number of players is less than 4, then we kind of want to return 4 because otherwise we're going to get too few AI. So 4 groups gives us around 16 AI, and then it returns the number of groups to spawn. And then this is a basic for loop. It just says, okay, for the number of groups to spawn, let's call our method spawn hunter killer group with a 5-second delay. Then what it does in our spawn hunter killer group method, it news up this entity spawn param. So basically, the entity spawn params are acquired by the spawn entity prefab function, and the params include a number of things, but we're basically just using them to give. We're using these params to give the location for the spawn point for the AI. So we take these params. And we execute a method called get spawn point for AI. That thing returns a bool, which is just whether or not it's found a spawn point, and also it takes in the params variable, and it outputs it as well. So basically, that's just, okay, we want to determine, okay, have we found the spawn point, and also we want to get back the position of the spawn point, which we will add to the params as part of the method. So if we go down to that method, so our load locations function that we executed first, that gets stored in the variable m_locations. Then we iterate through all of those locations. And for each of those locations, we execute this member method called getClosestPlayer with the location.getOrigin. GetOrigin is effectively the Arma Reforger equivalent of getPos in Arma 3. We give it this first variable, which is 250. So the variables it takes is distance away and max distance. Distance away is how far away does this point have to be from the player, and the max distance is how far away from the players do we need to search. So basically what this is saying is get the closest player that's further away than 250 meters from this location and closer than 1,000 meters away from this location. It's basically a safety barrier from 250 meters away from the player to 1,000 meters away from the player, so 750 meters of radius. That is the section we want to search for a location. Because if we search too close to the player, we run the risk of spawning AI on top of the player, and if we search too far away, we run the risk of spawning AI that will never make it to the player. Basically what this thing does is it loads the player manager, and it does that by using getGame.getPlayerManager and casting it as a player manager. Then it uses the player manager to get all of the players, and that this players thing that comes back is an array of types integers that returns the player IDs from the match. And what you then do is loop through that array with the player ID. With the player IDs from the integer array, and you load each player entity and get the origin of that, get the position of that player entity. And then you return the closest distance and the closest player. You mark the closest player as that object. And as you iterate through, obviously, if the distance is closer, then you get a different location. You get a different position. But effectively, what this does is it just loops through all the players, gets the closest one that fits the parameters for the getClosestPlayer function, and then it returns that entity. Right. So then what it does is if it can't find one, so if no players fit the parameters or no players fit the criteria for this function, then what it'll do is it'll return null as the closest player to that object. And if that is null, then we do nothing. And if it isn't null, then we can insert the locations into a temporary array of locations, just so that we can figure out, okay, well, what locations are we interested in using for those spawns? Then the last thing we do is we check, okay, are the locations available bigger than 0? If they are, in other words, we found a place to spawn the AI, then we'll continue. Otherwise, we'll log an error and return true or false, basically, whether or not we found a spawn point. So if we do find one, then we take that params variable I mentioned earlier. We access the third element of the transform object, or we access the fourth element, I guess, because it's the third index of the transform object, and we get a random element from our locations array. So one of the locations available, we pick it at random just to sort of mix up where the AI might come from, and then we get the location of that object, and we load that into our transform object inside of params. Right. So that's basically what handles the spawns for the AI. Once we have a spawn point, so if we have a spawn point, then we can go ahead and try and spawn the group. If we don't have one, we'll obviously want to log an error and just end the function out, right? If we do find a spawn point, then what we do is we get the name of the group to spawn. So get group to spawn is this function down here, and that optional parameter I mentioned earlier, the enum. That houses the faction in which of the AI we want to spawn. In Arma 3, you could do some config file magic to load a faction and find some groups for that faction to try and randomize things. But in this particular case, because of how things are structured, I could not find a way to automatically load prefabs for groups. So what I did is I found the resource names for those prefabs and inputted them here. So the way to get a resource name for a prefab is to go to your resource browser, and you can see here that that there are a couple of prefabs that manage the groups for the AI. So if you were spawning the AI manually, what you would do is you would go to this this prefab, and you would drag and drop it into the map, and you'd end up with a group over there. But in this particular case, what we actually want to do is we want to copy the resource name. And once you've copied the resource name, if we go back to our script, and I'll just paste it somewhere over here, you can see that the resource name comes out as this. So if you want to get some custom groups going, you can create your own group prefabs and then just get the resource name for those prefabs, and you can feed it into the group spawner. So obviously, in this particular case, I've hard-coded a couple of arrays full of groups for the FIA, the US, and the USSR. And what this thing does is it opens the or it gets a random element from that string array and returns it as the group to spawn. So once we have the group to spawn, then you call resource.load on that. If the resource, if you want to test that the resource is in fact valid, you call resource.isValid. In this particular case, if it's not valid, I fail this thing, leave an error message and return. If it is valid, then what we can do is call spawn entity prefab. So spawn entity prefab is basically the thing that'll spawn your group for you, but it's not just a group spawner. It'll spawn any entity prefab. You'll see now that I use the same thing to set up waypoints effectively. So you call or you use getGame, which will return the game instance, and then spawn entity prefab. You give it the resource that you've loaded, null, which is the center parameter, and then params. So the middle parameter is a base world object. You don't need to supply it, so we don't supply it. And then params is the parameters that in which we set the spawn point for the AI previously. You then get a group object out of that, and then you can obviously test the group to see if the group was able to spawn. And if the group is able to spawn, then what we do is we invoke the hunter-killer group lifecycle, and this thing is what manages the groups themselves to make sure that they continue to track us, and if they die, they respawn. If they're been going for long enough, they've switched their waypoints to ensure that the players are effectively always followed. So if we go down to the manage hunter-killer group lifecycle, the first thing we do is we check if the group is still active. The reason we check this is because if it is null, we actually want to invoke the spawning again. This is just the recursive mechanism it uses to ensure that the AI are continuously respawned in an automated fashion. Then what we do is so if the group is not null, so if this group is still alive, what we do is we look for the closest player. And that's, in this particular case, is the closest player within 1,000 meters. If the closest player is not null, then what we do is we confirm that the group still has agents in it. If the group does still have agents in it, then we create waypoints for that group, and then we reinvoke this function in 30 seconds. So basically what this thing is doing is it's ensuring that the group is always fed with up-to-date waypoints for tracking the players. So if we go quickly through to the create waypoints function, what this thing does is it gets all of the existing waypoints for the group and it gets rid of them. The reason it does this is so that it can refresh the waypoints so that the AI are always tracking the player. Obviously, if you want to create a custom set of waypoints, a patrol pattern or something like that, you wouldn't remove your existing waypoints. Then what it does is it calls a method called getHunterKillerWaypoint. And what this thing does is it looks for the closest player once again. If that closest player is not null, it creates a waypoint, and then it sets the origin of that waypoint, so the position of that waypoint, to the closest player, and then it returns that waypoint. When the waypoint comes back, the first thing we do is check, is the waypoint null? If it is null, we logged that we were unable to create waypoints for the group, and we returned false. If it isn't null, then we add the waypoint to the group and return true. Right, so let's say it wasn't able to find the closest player. So we're back in the manage hunter killer group lifecycle. When a player is not nearby, we actually need to reset that group. Otherwise, so if the group's fallen too far behind, or the group is entirely dead, we need to restart the cycle of scripts so that there's always the same amount, effectively, of AI tracking the player. So in this particular case, if there's no closest player within 1,000 meters to the group during the group life cycle, it takes that information and says, okay, cool, players aren't close enough. This AI is likely never to catch up to them. So we effectively kill all the AI in that group, and then we reinvoke the spawning process. So that'll restart this whole life cycle. So the way it does that is it takes the group member. It loads the entity for that group member, so it calls group member.getControlledEntity, so that's the AI agent. It creates the damage manager for that entity, and then it sets the health on that damage manager to 0, which is effectively just killing them. And then if it removes all the agents, it calls spawn hunter killer group again, and it restarts the life cycle. And that is basically all of the functionality. So if we backtrack just a little bit and we go back to our AI group, this particular line here, this spawn entity prefab, is probably the most useful part of what you've just witnessed, because it effectively allows you to take any spawn entity, entity, or any prefab specifically, and spawn it on the map at will. And that information, I'm sure, will be invaluable. Now, obviously, just to prove I'm not talking out of my ass, I'll quickly take you through how this thing actually works, and you can see it in action. So obviously, there's that location loading that takes place, and then a bit of initialization that needs to happen before the groups spawn. And while I was explaining that, the groups have spawned. So you can see here, it set up some of the groups. Obviously, because this is happening quite quickly, you can see it sort of like put them inside of one another, because they all spawn pretty much at the same time. This group spawned down here individually, and then our other 3 groups, because there's only 1 player, it spawned 4 groups. They spawned up here at St. Pierre's Pass. So obviously, the get random element function is not a perfect way to do this, because it is random, and by the nature of randomness, you can end up with the same area more than once. What might be a more fitting solution would be to collect the number of locations around, and if that number of locations is bigger than the number of groups you want to spawn, you can distribute a group to each of those locations. But obviously, that'll be something that we look to do in the future. But for now, I mean, this functionality works perfectly. So then the other thing we can do is we can kill one of these groups just to ensure that the spawning happens again for that 4th group. There we go. That was our 4th group spawn. And you can see here it is selected Larens as the point for spawning. Okay, so the next thing to do is to just quickly show you what happens if we get too far away. So say we miraculously outrun them by teleporting through to Montignac. So here's our remaining groups. As I zoomed in, you can see that all of them were murdered. So there's no groups here anymore. Oh, interesting, that group spawned at Larens. Oh, no it didn't. It's dead now. The rest of the group spawned over here by Montignac. That must have been on an interesting cycle. So we got 1 group spawning at the farm over here, 2 spawning at the industrial, and the last one spawning at Entredeux, or Entredeux, however you pronounce that. Yeah, so that's effectively it in action. Now obviously these guys will continue to follow me as I move, so if I don't move too far out of their radius, their waypoints will readjust and we should see them coming towards me any second. So they're currently headed to my last known location, and once the waypoint updates for my changed location, they'll shift positions to go after that. So this is more of a demonstration of how hunter-killer works, but obviously hunter-killer by its nature is a scripted functionality. and it's really difficult to try and do this, without scripting. In fact, it's near impossible to try and do this without scripting unless somebody has figured out a way to attach entities to other entities. Like perhaps a move waypoint can be grouped into a prefab with a character. I don't know. But yeah, there you go. You can see they've changed direction. They're coming after me now. Cool. That's pretty much all I have to show. I think I maybe went through things a little bit quickly. And obviously, for those that are not familiar with object-oriented programming, there are probably a few concepts that will take a little while to understand. But as I said before, leave a comment. I'll try and explain as best I can. And I guess until next time, I hope to see more scripted scenarios popping up onto the workshop.